Okay, gang, let's do number 5. So this is the equation, and you want to take the derivative of it. Now it's a variable times a variable, so you're going to have to use a product rule. So that's what I'm going to do now. So first, times the derivative of the second piece in respect to time, plus the second times the derivative of the first in respect to time, and the derivative of a constant is 0. Alright, so that is the derivative. Now let's start to look at what they want. So part A here, let me see what they're saying. They're saying find dy dt when x is 8. Okay, find dy dt when x is 8, and they're telling you that dx dt is 10. Alright, so part B is going to be similar to how I'm going to solve this. So watch how I do this, and you'll be able to do part B. So this is the question, find dy dt. So I'm going to go ahead and isolate dy dt. So for me to do that, I have to subtract this to the other side. Technically you can plug in first and then isolate. I just like to do it this way for various reasons. It's more like applicable in the real world when you do it this way, because the parameters change but the equation is usually consistent. So isolating the equation still keeps it relevant no matter when your situation changes. Sometimes the equation changes, but if you plug in all your parameters up front, then you have to do everything over versus just plug in your new parameters. All right, gang, so let's plug in now. So, okay, so some of you might be like, well, wait a minute, they didn't give us y, but they did. They just did it implicitly. They gave it to us implicitly, because if you know x times y equals to 4 and they tell you x is 8, right? If they say x is 8, that means 8 times y equals to 4. So if I divide the 8, y equals 1/2. So just don't forget that sometimes you have to like find stuff. It's not like explicit. So I found y and now I can plug it in. Dy, no, hold on. What did I write wrong? You guys probably noticed and I didn't notice. Okay, I'm sorry. Always give me a chance to back up if I faux pas, which I, as you can tell, I will do here and there. Alright, so I fixed it. We should have been dx from the beginning. My bad. Alright, so now times dx, which is 10. Yeah, please be a little patient with me, and I know you guys are. I will usually be able to correct myself when I screw up. I'm not used to filmmaking, and it's always nice when the students in class say, hey, Professor Whelan, you just did a typo there. I don't get that lucky. The camera never tells me when I make a typo. I wish it would. Camera, you need to start speaking up. Okay, so half of this is -5/8. All right, so that's the final answer, and there's no units here because we're just doing it sort of as a generic example. All right, so you guys, I'm sure now can do part B. So part B, first isolate dx dt. Plug x into the equation, let x be 1, which would mean y is 4, and plug in your values, and you'll be able to find dx dt in the second example. Alright, gang, I hope that helps. Catch you. Bye-bye.